First with format of the test. So we've got test 3. You could expect, again, multiple choice, short answer, and then math. Proportionally, I'll give you an idea. I would say probably, here's going to be my breakdown for this test. I'm going to say short answer is probably 20%. Multiple choice, it's probably 40, 20, 40 this one. That'd be my breakdown for you. Maybe 30 for short answer. Actually, yeah, it will be 30 because there's a couple questions I still need to add to that. So these might drop to like 35 and 35 actually. Okay, but you can think of it as being split down the middle for the most part, maybe with the middle part being a little bit less than the others. Yeah. If you want to be practicing something tonight, honestly, the best thing to practice is the math problems because the math lend you also more help on the multiple choice. The theories in the math problems come up in the multiple choice. Yeah. Okay.
What kind of question would you ask for a short answer?
So, okay, imagine like a short, and I'm coming up with this off the top of my head. This is not actually a question or test, but the type of question you can expect. You can expect something such as, you see a path of a projectile launched maybe from the ground up to a ledge, like you're throwing an object up to a windowsill for some reason, and you see the path of it, right? And I put maybe 3 or 4 points on the path, and they tell you to explain to me how the velocity changes along the way. What's happening? So you'd have to say that the x velocity is always constant, remember, the whole way. But the y velocity on the way up is positive, at the top is 0, on the way down it's negative. So understanding how the components of velocity work, that could be a great example for that. That idea you need to know, whether it's in the math, the multiple choice, or short answer, what I just represented. So it might not come up as a short answer, but that's the kind of question you can expect, where you're given opportunities to present what you know about the trajectory of an object. Yeah?
Okay, and I guess this is more like specific question, but for the math, for the number of problems or how many there are, they wouldn't necessarily be that hard.
Yeah, so I would say time-wise, because that's definitely a concern some students have, because it takes them a while for the math problems. I would say you're probably going to have 2 lengthier ones, 1 shorter one.
Okay.
I usually give 4 math problems, 4 and sometimes 5, but the last test I think I gave you 5 and had you choose one of 2 of one of them, right? So it ended up being 4 problems to do. So these are a little bit longer, so they probably have 2 problems with like maybe parts A and B, and then 1 problem that's a little bit shorter than the other 2. Okay? That'd be my guess, but honestly, I have not made the math part at all. Every time I make these tests, I always try to change a lot about the test. So the math part I have not even looked at yet. For problems like this, on your lab, you were asked to talk about the max height, the range, the time of flight, those 3 characteristics as theta goes from 0 to 90. That was a question on the lab that a couple of people really botched, so I want to go into. I'm going to go over a few of the lab questions because I didn't turn them back to you, so I want to mention these things that as a whole the group really struggled with in the lab. This is going to be one of a few. So the first thing I was thinking about was this. As theta goes up, I'll actually draw it on the diagram because I was talking about it in the other class, but I never drew it out. Let me draw it out so you can see. So let's assume it's launched this way at first. What's that angle? 0 degrees. Then it's launched all the way up to 45 degrees. As it increases from 0 to 45 degrees, what happens to the max height, the time, and the range? It's one answer. Make it easy. They all increase. So y max, time of flight, and the range all increase. Yes. Oh, jeez. Yes, hold on. It's because it's glare today, huh? All right. I can change the template, I think, just to go. Range all increase. But what happens after 45? This is what a lot of people forgot to mention. They said from 0 to 90, they all increase. They don't all increase. What happens after?
T and X decreases. Y max.
Y max definitely increases afterward. So imagine now we're at like an angle of like 80 degrees, right? That's what we're looking at? So it does this now. So Y max definitely increases. X definitely decreases. What does T do actually? What does T do? Increases. Where's your evidence from this? Where's Curtis? Where are you making this statement from? Do you have any?
Well, I think it's because the hang time is much longer because you're actually shooting up. Because what's it called, the velocity in the X just doesn't change at all.
Yeah, and think about how you solve for the time of flight. Usually it's the y direction you get the time. And VIY is a direct impact on that time. So you're increasing VIY inherently, and you're changing the equation. You're allowing t to be a greater number. So we have these values here. Again, t increases, y max increases, but x decreases. Okay? X decreases. X represents the range. And we can see that instead of going the full flight, it only goes a portion of the flight range. Okay? A second question from the lab that was misconstrued. Not misconstrued, but not answered really well. The question was, how do the paths differ between when there's air resistance and when there's not? Explain the reasoning and why it happens. A lot of you gave great answers and said, there's smaller range, smaller max height, less time. All true. All things very true. But the question said, explain the reason, explain what's happening. Not many people did a good job of that. So you got like half the problem right. Why does it physically happen? What's physically going on? Give me some reason. The what? Okay, so it's not symmetric for sure. That's one thing you can state, but that's not why. My question is, why is it physically not going as far, as high, as long? Yeah.
Isn't it contact with the air creating drag?
The air is creating drag, exactly. The air is pushing against the motion of the object. What is that creating, actually? And this is kind of even a little bit more difficult. Mathematically, it changes one of our variables that we've made an assumption about all year.
Acceleration?
Yeah, AX. We keep saying AX is 0, isn't it? Every time we say AX is 0, it's a constant velocity. But in reality, the wind pushes against the x velocity and it pushes down when it's on the way up, and it pushes up on the way down. It opposes the direction of motion. So again, it creates a negative x acceleration. That's the mathematical reasoning, and the literal reasoning is what Will said. You know what? Instead, it actually just opposes the motion of it. Instead of, when you launch it, it helps the motion or it assists its motion. I feel like there was one other thing about the lab I wanted to mention. No, I guess that was mainly it. Oh, here, that's what this one was. Yep. It just popped in my head. I didn't even see it. Here. This is something that was not obvious, so I did not reduce points on the lab as a result of this because it wasn't really obvious. Because unfortunately, the simulation, I don't know. I feel like the simulation should be spot on because it's a simulation, but some of the answers I've noticed are not necessarily always perfectly reliable. And let me explain what I'm getting at. Do you remember the question number 99 on your problem set, similar to the question in the lab with the quarterback? The quarterback could throw a low pass, or the quarterback could throw like a high lofted pass. So you had these two trajectories. The lofted pass here on the lower one, the time here, T1, we know is less than T2, obviously. Right? Y max 1 is less than Y max 2. X1 is equal to X2. Right, these are all things you should be able to state automatically by looking at this. Again, call the top one 2, call the bottom one 1, all right? Now, what did you notice, and this was difficult because I don't think anybody got this, maybe won't even be able to answer. But what did you notice about the angles? Did you pick up on any of this? And it wasn't obvious because it didn't exactly work in the lab. That's why it's hard to say. So for example, if the bottom angle, anybody remember their data for this? I remember generally what it was. Most of you answered with the answer of 12 degrees for this one and around 75 or 76 degrees for this one. Anything about those numbers? So yeah, it's not obvious. What do you think?
That they're kind of opposites, I want to say.
Okay, so
difference from the higher number to 90 and then from 1 to 0.
yeah, it should be exactly what he's saying. What's the word for that, guys? What's the word for what he's describing? Complementary. The angles should actually be complementary. They did not turn out that way in the lab perfectly. I know that. So again, I didn't make a big fuss about it when I was grading them, but I want you to know that, okay? To create the same range, the same x displacement, the angles simply need to be complementary. Part of the reason it didn't work out this way in the lab is because it started at a level that was higher than where it ended. Did you notice that? In the lab, it started here at a Cannon level, and notice that y was always negative 1.2. Remember that number kept popping up on the lab? That's because it started here and ended here. So the drop was 1.2 meters. And the drop was 1.2 meters. This was just a reduced sample. Okay, that's the main ideas from the lab. What questions do you want to ask? Again, aside from question 99, what other questions have you been struggling with? Simply because, again, I already went over that. George.
Well, 92 in the problem set.
Is it?
92.
Do you have it written down by any chance?
I don't know.
That works. This is problem 92, George is asking about. 92.
Anytime run is measured to be 4.5 seconds, if the ball is taken at an angle of 63 degrees above the horizontal and was not at the same level from which it was taken, what was its initial speed?
So based on what she said, that's what I'd write right off the bat. So, time of flight.
Why is y equals to 0?
Why is y equal to 0? What is the statement in there?
It's not at the same level from which it was taken.
There you go. So that's the key. And then once you get that, I'm sure you can go through, right? What is the problem asking? VI, right? VI? Yeah. So again, remember, this is in the y direction, the information that you're given here that you use. So in the y direction, you've got y equals VIYT plus 1/2 AY t squared. So you got... Now, by the way, there's another way to do this. I'll do it both ways to show. So this is going to be VI sine 63 times 4.5 minus 4.905, 4.5 squared. Okay, does everybody see what you would do for this problem? Take a look. Make sure that makes sense. You would solve for VI. It's the only variable missing in the equation. It's kicked from the same level it's caught, which makes y 0. VIY is always VI sine of the angle. The time is 4.5 seconds. That's squared down here, and that's half of gravity. Now, there's an easier way to do this. Not easier, but might be mathematically a little simpler. You know what I was going to say? What's the time to max height? How much time elapses to max height? Come on.
Oh, 4.5.
No, to max height. Yeah, which is 2.25. Was it the math? 2.25? It's half of it. All right, we get that? Half. So you could have done this instead. VFY, when it gets to max height, is what? What's the velocity at max height, people, in the y direction? 0. That's times, okay? That's what you could have done also and solve for VI. This might be easier than doing all the math up here, but either way works. Again, I take half of the time in the approach in the blue ink here, and I say that the velocity at the final, meaning at the top is final now, is 0. This is VI still, which is VIY. It's VI sine 63, and that's gravity, negative 9.81 times the time of 2.25. Either equation can be solved. Okay, either equation. Either approach is fine. Did I need the x direction in this problem? No. The x direction was not even necessary in this problem. So tomorrow, when you take this test, you should definitely be ready for a problem like this. That's like the shorter problem. Remember, John and I said there's going to be two longer and one shorter? This would be like a shorter problem because you don't even need the x direction. Is that clear what I'm saying? It would be a problem where like I'm asking you, find the max height or find the time to max height. Where you probably use this equation, or the VF squared equals VI squared plus 2AY equation, and you only need the y direction itself. Okay? Expect something like that. Yeah?
You know how sometimes find the initial velocity and find the x and the I when we do it, the something. Why wouldn't we do that?
So, yeah, that's a great question. When you're finding like a final velocity that has two components to it, that's where the Pythagorean theorem comes in. When you're finding a final velocity. So when you're finding initial velocity, it's only a variable that shows up. So remember, this number, say this number is 20, right? Then the y velocity is 20 sine 63, it would be like 17 or something like that. And the x might be 12. So the 17 here and the 12 here, those squared is what makes up the 20 that you're solving for here. So you don't need Pythagorean theorem when you're finding initial, ever. You're never going to need it. Okay, it's not going to happen unless for some reason you're given VIY is this and VIX is this, then you just use Pythagorean theorem to solve. But because you're giving it as a function of the actual variable VI, you can solve simply for VI, and that is the initial velocity. It's at the end, when you solve for final velocity in the y, you already have v bar x, you put those two together and use Pythagorean theorem. Because remember, v bar x is the same the whole path. So at the end, you use that v bar x with whatever you solve for vy at the end. Then use Pythagorean theorem. That's only at the end of a problem, so maybe here, or here, at some point along the way, assuming this is the beginning. That's when you would use Pythagorean theorem. And these are good questions and good things to jot down. All right, again, the question was, when would you use Pythagorean theorem and put them back together? If you're trying to find the velocity at some instant in time, yeah, you know the v bar x is always the same, but at that instant in time, you could still at least solve for vy in that case, and then use Pythagorean theorem to find the velocity. Another hand was going up somewhere.
You have a problem, or I don't know if you answered this, but would that be a problem where you solve for time and also use your calculator?
You should definitely be ready to use your calculator, and you definitely need a calculator. Absolutely need a calculator. You don't ever need it to solve, though, because you could always do the quadratic formula, but I would approach it with a calculator approach because the graphing method is so much faster. It really is. It's so much faster than going with the quadratic formula. Okay? Quadratic formula takes forever. It's not worth your time. Go right to the graphing method. You could even, honestly, you could write a program to do the quadratic formula. It's really simple. It's like 6 lines of code. I could send it out later if you want. If you know how to do it. I don't have the time to be doing it now, but if you want to do it on your own, I could send out an instruction manual. It's like literally, the line of code is this long, and it's very easy to do it. It's very simple. And you run a quadratic, you run a program, and it says like S, it says what's A, what's B, what's C. You type in the A, B, and C values, hit enter, it calculates the answers for you. It does the quadratic formula in the calculator, and spits out the answers. If somebody reminds me, I could do it later, I could send it to you. I just have to find it. I have an old file with instructions on how to do that. What other questions? Yeah? With the graphing?
Yeah.
Can you come by during a free? I'll go over with you. Okay, because a lot of people have done that already. I'd rather talk about topics that we're on. What are the questions about the test, about the actual physics behind this do you want to go through? There's got to be more you're thinking about. Yeah?
I mean, for me personally, it's not the physics part, but when we're going through the problem, it's like the missing gaps from like the algebra knowledge. I guess like I just kind of get confused on it when we're solving a problem, and it's like no longer like from the formula. It's like trying to apply like our algebra knowledge. Like that's kind of like when I get confused.
So you already have the stuff in the formula you're saying, and then going through the process of solving at that point.
Yeah.
All right, so let's just maybe do an example or two of another math problem. Maybe that'll help go through the process. When in doubt, though, what I always think, and I keep asking you guys this, is what's happening to the variable? And do the opposite to that. So if you need to move something that's being added, subtract it. If you need to move something that is currently multiplying, divide. It's when you get to like squares, you have to square root it. When do you square root it? That could be a little bit tricky. So let's say we have a problem where an object, how much time do we have time-wise so I have an idea? 47, yeah, so we still have like 10 minutes, perfect. So let's say we have an object that is, I don't know, let's say it's launched up to another elevation, okay, and we'll go into calculating the velocity at the end. So it's at an elevation on ground level, we'll say to start, and an object is launched up to another elevation level, okay. I don't know if it's on the way down or up, I'm just drawing a diagram for now. We know that the height of this second elevation is 12 meters. We want to determine the velocity with which it should be thrown. We want to determine the velocity with which it should be thrown, which I'm asking for VI. If it's thrown at an angle of, let's say, 70 degrees, and let's say it this way, and the distance from the actual ledge is 7 meters. Okay, that's our question. Determine the value of the initial velocity such that this works. And I purposely did initial velocity, Jana, to make it kind of difficult to solve. I was ready to sort of practice it. Okay? So VI is difficult to solve for sometimes, so I'd rather start with that first. So let's list what I know, in what direction, what do I have. In the other class, you know what I did with them at the end of the period? Here's what I did. I said, you guys need to start every single problem with the same thing. And I'll show you what I was telling them. Every single time you start a problem, you can start with this. Always with this. you can then follow up with this. Oops, it's 70, right? So this is always a good starting point for every problem, okay? Now, in the x direction, you're always going to only have one equation. That's it. In the y direction, though, you have several options. So let's list what we also know. The y value from start to finish is what? From start to finish? 12. And this is one of those cases where it's positive, because we're throwing an object upward, not where it's being pushed off a ledge or a cliff or a building or something. And the x is to the right, so we'll say that's also positive. So that's enough for my diagram. I don't need it anymore. I can get rid of it now. Notice that? Isn't that interesting? Once I've written all that down, do I need the problem anymore at all? No. That's why it's so important. What's it asking for? What's this problem asking for? Initial velocity. And notice, Gabe, take a look. That's what's unknown here and here, right? Because that's what we're looking for. Yeah.
I know you don't really need time for this, right?
You know what?
You don't need time for this?
Are we going to need time for this kind of a problem? I think we are.
Yeah. And
Well,
to get the
no,
y
we are.
equation.
Yeah, because unfortunately we can't, if we set VFY equal to 0, that's assuming it's the max height. We have no information about VFY. So we're missing VI and time. We're going to need to solve simultaneously again. So let's take a look. Let's say we've got, in this case, we're going to search for time, because that's what can link these two together. And we think about this problem and say to ourselves, well, what equations are possible? In the x, it's always the same thing. So you could also always start with this. And unfortunately, we're missing VI. And we're also missing time. So this presents us another setup. Actually, this is very close to the other one that we just did. They're very similar. Almost the same in nature. Can I change this at all? How about this? I'll mix it up. I'll say that it reaches, just to change things, I'll say that it reaches the window when it hits max height. So let's just do this now. Make that the max height, as if it would continue downward, okay? So let's say it reaches the window at max height. It's still y. Y is still 12, so we don't have to change that. That's the good part. But that allows this problem to become a little bit easier. Oh my gosh. So if that's true, and it reaches the window at max height, I can do a lot more now. I can make life so much easier. I don't even really need the x direction as much anymore now. What could I do?
You can set it to 0.
Set what to 0?
Set x to 0. I mean y to 0.
Just y?
Yeah.
You're on the right track. You have the right idea, Gabe, but you're not saying it right what you need to do. You're not setting x or y equal to 0 in this case. But you're on the right. I know what you mean, but you're not saying it right.
The final velocity
In what direction?
in the y.
To equal
0.
0. It's the VFY, okay? VFY. So the reasoning, again, is because as this object travels upward, what's happening to its vertical velocity? Gravity is slowing it down. Gravity is pulling down on it when it wants to go up. You guys remember from last chapter, when an object wants to go up and it's being pulled down, it's got to be slowing down, right? Moving up, but it's being pulled down, and then it slows down, and it stops at the top. And then it starts to fall back down and become negative. So we could set VFY equal to 0. And as a result, we could easily solve for time or for VI. Now, which equation would I use? Would I use this? Or this? Which equation would I use? What do you think? And again, we're trying to find VI is the actual question. Find VI. Ernest. Yeah, I agree. We could use this one, and we'd be missing time and VI, right? Again, VIY is VI sine 70. We'd be missing time and VI. We'd be missing time and VI. We'd have to solve simultaneously if we use this one. It doesn't make sense to do that. You're given the max height. It's 12 meters. You're told it reaches the window at max height, so y is 12. So use this equation. So this equation becomes 0 squared equals VI sine 70 squared plus 2 times A times Y. Notice VI is squared and sine 70 is squared. So the way to do sine 70 squared is to actually just square the sine of 70. So literally do sine 70, hit enter, and then square that number. And give me like 4 decimal spots for that one, please. So VI is squared, I know that. It's times some number. And then on the other part, we're going to have a minus at the end here. What do you got, Ernest?
0.8830.
That's what sine 70 squared is, correct?
Yes.
Okay. Now 2 times negative 9.81 is negative 19.62 times 12. What is that on the right-hand side there? We have like a minute, so it's your time right now. Go. Point. All right. So we take that number and move it over. So here's the algebra. Ready? I add this number to both sides because eventually I need to get VI by itself. But I got to get rid of what's here because this is like having 2x plus 5. I would move the 5 over first, right? It's the same thing here. So I move that over first. So it's left with this. Then I get rid of the 8830 because it's currently multiplying. Remember, even though there's a square here, you don't take a square root until you get this whole thing by itself. You got to get this. This comes up a lot with t squared also. So divide by 0.8830. What do I get from that? 235.44 divided by 0.8830. Ernest?
Negative 266.63.
Positive 266.63. It's got to be.
Yeah.
And then take the square root. When you divide by 0.8830 into 235, it's got to get bigger, so that sounds reasonable. And then, Amaya, what do you got?
Yeah.
Is it positive or negative? Why positive?
It's going up.
Positive because it's going up. Would you agree? Yeah, also think about the problem and the nature of it. In the beginning of this problem, this is the VI. And VI is kind of launched at an angle, isn't it? So it's positive in both x and y, actually. It's kind of a weird answer. Because remember, this is not VIY specifically. This is generally just VI here. Remember, Juliet? This was your question earlier. This is VI. Whenever solving for VI, we don't get VIY. We don't keep VIX. VIY was right up there. See the VI sine 70? I'll point to it. This is VIY. And VIY is being squared. Once we got rid of the 0.70 or the sine 70 here, and it became this, and we squared it, and then we divided by it, we got this by itself. This is VI itself. This is the initial velocity overall. So you could say that this object was fired at 16.3 meters per second at an angle of 70 degrees. That is not VIX, that is not VIY, that is just VI, the overall initial velocity it's launched at. If you want V bar X, you would take 16.3 times cosine 70. If you want VIY, 16.3 times sine of 70. This is VI that you got here. So in reality, even though it's plus or minus, it's got to be plus because our angle is what gives us its direction anyway. Yeah.
But if we were doing this problem, we have would we have to put plus minus?
You should always put plus or minus on anything when you take a square root in any equation in math. Anytime you're solving an equation, when you take a square root, it's got to be plus or minus. It doesn't matter. Time also. Time, VI, VF, all of them. It's your choice to make the decision based on the context of the problem, whether it's negative or positive. That becomes a little bit tricky, right?
Yeah.
So again, tonight, watch the other classes for number 99 if you'd like to see that. And that's the only additional thing I did on top of this. Tell them, please, I'll email this. Tell them, though, to watch your section because I did different.